So last year I saw two games go very viral. One of them was the punching machine and another one was the reaction machine. Now in my area, although I saw a lot of punching machines, I did not see many reaction machine. So I made my own. Okay, so I have three requirements for this project. One, it has to be very simple, so no complex build process like 3D printing, custom design or anything. Number two, it also has to be very cheap, so easy to find materials that are very cheap and does not break the bank. And number three, which is the most important to me, and that is it should be very modular, so it should be very easy to assemble and disassemble, so it is not sitting permanently on my room, and I should be able to power it with something like a power bank. The structure of this will be very simple. I'll be using this PVC pipe which I got for very cheap, and it is also very easy to work with. So all I did was cut it in size and make two holes on each side. And I'm also going to use two of these tripods. These are not only cheap but they're also very versatile. I can adjust their heights and whatnot. So all I do is use this hole and mount it here, and I'll have another tripod on this side. That way they'll be standing and I'd be able to adjust the height as I want, and like I said, it is gonna be modular, so I should be able to just disassemble them and put them aside whenever I want. And for the bars that will fall and will catch, again I'm going to just use the same PVC pipe cut in shorter length. And as far as the electronics goes, the heart of our project will be this. This is an Arduino Uno, and this is basically a very tiny computer. So just like our regular computer, this also has a processor. This has a pins which you can think of like USB ports, Ethernet ports, etc. The only difference is this is cheap and very weak compared to our computer, but we'll be able to program it and we'll be able to hook up some input and output device in it, so we can control all the electronics using this. As far as the bars, so initially my thought was I'm going to use an electromagnet. So electromagnet typically is not magnetic, but when you supply some voltage to it, it becomes magnetic. So my thought was I would just stick a piece of metal or magnet in it, and then it would be held using the electromagnet. So initially I'll power the electromagnet so it is magnetic and it is holding the grip, and then I would just cut the powers and it would fall. It would be very simple. But I couldn't find them in the place where I usually shop for electronics, and they were kind of expensive online, especially since I'll be needing at least 8 or 10 of those. So this was quite a problem for me, but after thinking for some time I found a solution, and the solution was servo motors, and a lot of them. So the way these will replace the electromagnets is, first let me show you what I did on the grip. So you'll see I have this hook like thing here. So all I did was I got some steel wires. These are very cheap, you can find them anywhere in hardware store. I made two holes in the pipe and all I did was bend them and join them. So now we have this. So now we have this structure, and what would happen is we'd have a servo motor like this in this orientation or something like this, and then we'll just hang this here, and instead of electromagnet releasing them, all we do is rotate this head or rotate this attachment and it will fall. So this should work, and this is a very cheaper alternative. Okay, but what even is a servo motor? So we all know about DC motor or normal motors that we probably harvested from some toys or something. Now those motors will spin continuously. The difference between a normal motor and a servo motor is we can control the specific angle. So if I tell it to like rotate 90 degree, we should be able to just rotate this attachment from here to here. So this is very precise, unlike a DC motor. So what I did was, initially we didn't have any attachment, and then I wrote a script that would rotate the head in 180 degree and then attach the attachment. So I know all the servo motors are in 180 degree position when the attachment is horizontal. And then the plan is to just simply place them here, stick them here using zip ties or super glue, and we'll have a lot of them, hopefully about 8 of them. And the bars will be like this initially, and when the head rotates they'll fall. So now let me just stick all the servo motors here, and this is the contraption I came up with. So I have simply super glued 1 2 3 4 5 6 7 servo motors. Now my problem here is each servo motor requires 3 connection wires: a ground, a voltage, and a signal. Signal is the connection that we use to to tell the servo motor on what angle the head should rotate. So now we have 7 motors, we'll have a total of 21 connection wires, which is a lot. So I want to create a adapter wire real quick. Okay, so after hours of connecting wires, this is what I came up with. Now this looks like a mess, and it is, but this is actually less of a mess than it would have been if all the servo motors have individual connections. Since all of the servo motor requires 5 volt, so what I did was gave them a common positive and negative wire and only unique connection wires. That way, instead of having 21 total connection wires, we'll now only have 9 wires, which is much less. And one problem you might think I have here is, although the power wires are easy to spot, the connection wires are a mess. I don't know which wire belongs to which motor. But actually that's great, because this game does not execute each servo motor consequently. Instead, they are random. So if my connections are random, or I don't know which one I am sending the signal to, that's completely fine. It's not a bug, it's a feature. So yeah, what I'm going to do now is just use some tape to make them a little bit nicer and then start coding. And this is how this looks like after a little bit of cable management. Still not the prettiest, but they should work. And I have also added these pins here, male header pins, and they'll basically help me to easily just connect them with my Arduino. And there's a few more components that we're going to need, so let me show you those. Okay, so I have a small breadboard, and this will help us to connect all the pins instead of manually twisting the wires. And then we have a potentiometer, and we're going to use this as a voltage divider. So basically when we twist them, we will be able to read how much we have twisted this, and that way we can sort of control the speed. So basically the delay between each grip falling. So the smaller the delay is, the harder it will be to catch them, because they'll be falling faster. And lastly, one component we also needed was a switch, so we can press the button to like start the game or something. But the thing is, I forgot to buy the switch, which is like very stupid of me, because it is one of the simplest component. So instead of pressing the switch, what I would do is just connect the wires manually, and this would basically act like a switch for now. And now let me walk you through the connection and the codes for this. And this is our connection. So we have all our servo motors here with common voltage and ground line, and then the connection wires are going from pin 2 to all the way to pin 9. So we have total of 8 servo motors, and then we have a potentiometer, and we are connecting the first pin to the 5 volt, the last one to ground, and the middle one to analog pin 0. And then we also have a push button connecting to pin 10 and ground. And we also connected this ground with the ground of Arduino, so we have a common ground. And let's go to the coding. And this is our code. At first we're including the servo library. This is a built-in library, so no need to install it. Then we're defining the start position of our servo and end position of our servo. So start position is where we'd hook all the grips or the bars that would fall down, and the end position is where it would go when the bar falls. Now we have number of servos, which is 8 in my case, and then I'm defining the pin, so the digital pin 2 through 9. And then we're creating an array of servo objects, and then I have a start button pin hooked to digital pin 10 and speed pin to analog pin 0. And in the setup we're calling the random seed function, so this will help us with generating random numbers. And we're setting the pin mode of start button to input with a pull up, and pin mode of seed pin to input. And at first what we're doing is shuffling our array, so we're just getting to index and swapping them randomly. This will make sure all the bars fall down randomly each time. And then in this loop we're calling the servo.attach function for each pin, and then we're setting all the servos at start position with a delay of 1 second between each. We're waiting for the button press, so since we're using input pull up, it will be high by default, and when we press it, it will go low. So we're gonna wait until the button is pressed and it goes low. Until then, don't do anything, just do a little delay. Once the button is pressed, we're gonna wait for 3 seconds, so we can basically go to our start position of playing the game. And then we're reading the value of our potentiometer. So the value of that will be between 0 and 123. And we're mapping that to 3 seconds to half a second. So if the pin is set to 0, the delay is only going to be 500 millisecond, and if the potentiometer is turned all the way up, then it will be 300 seconds. And then finally what we're doing is, in a loop we're basically looping through all the servo, which are now randomly ordered, and then we're setting them to end position with a delay of speed. and we don't have anything in our loop. So this is all the code that is required. And now let's try to play the game. And this is pretty much the finished product, and I know it does not look very good, but it is functional and it was quick to build. And as far as resetting it, the Arduino has a reset switch, so when I press it, the game will reset and I can start over again. And this is a Type-C port that I'll be using to power it through a charger or a power bank. And yeah, that's about it. So let's play it and see how it works.